Now we're going to spend a little bit of time talking about quantifiers. Remember that we have two quantifiers. We have the universal quantifier, which is represented with kind of like an upside down A, which means for all. And we have the existential quantifier, which is like a sideways E. And then remember how we negate these. When I negate a for all, the universal, it becomes, you flip it and it becomes an existential. Not QX, okay? And then the same thing happens when you negate an existential such that QX, it becomes a universal. So let's look at some statements and try to negate them. Negate for all integers n is even or n is odd. So what would the negation of this statement look like? Well, we've got to flip our quantifier. So it becomes there exists an integer n such that, and then you need to negate n is even or n is odd. This is an or statement. Remember how we negate an or statement such that n is not even or n is, it becomes an and n is not odd. Now you can use, instead of not even, you can use odd. Instead of not odd, you can use even if you want. Let's do another one of these. Let's say we want to negate there is a real number x such that x is irrational. So what would the negation look like? Well, this has the existential quantifier. So it'd be, switch it to the universal. So it would say every real number, and then we got to negate x is irrational. Every real number is rational. Remember how to negate. So I do want to mention this isn't a problem. We're just going to review this. Remember how to negate universal conditional statements. So if I negate for all x, if p of x, then q of x, well, you negate the universal part, so it becomes existential. There exists an x such that. And then remember how to negate an if-then statement, a conditional statement. It becomes p of x and not q of x. And you also have, for these universal conditional statements, you have the contrapositive, the converse, and the inverse. The last thing we're going to talk about is arguments with quantified statements. And we're just going to look at an example here. Determine whether the argument is valid or invalid by drawing diagrams. So the argument is going to say all teachers occasionally make mistakes. No gods ever make mistakes. Therefore, no teachers are gods. So remember, these were the problems where we used the kind of like Venn-looking diagrams with circles. So you take each piece and you draw a diagram for that. So let's say all teachers occasionally make mistakes. So how would I draw that in a picture? I would have teachers, circle representing all teachers, and then they belong to the group of beings that make mistakes. So beings that occasionally make mistakes. Okay, so we're going to draw our second diagram here, representing our second premise. So look here. What is our second premise? No gods ever make mistakes. So my circle representing, I'm just going to write it shorthand, occasionally make mistakes. Gods are outside of that circle. So here's a circle representing all gods. And so then we combine those two pictures together. And sometimes there's only one way to combine them, or multiple ways, but here there's only one way to combine them. And I get the following picture. I have teachers, people that occasionally make mistakes, and then I have gods out here. So we're going to look at our conclusion. The conclusion says no teachers are gods, and if you look, the teacher circle here and the God circle don't overlap at all. And so no teachers are gods, so this argument is valid.